You've just accessed Hardware is Forever, your source for the expert insights, ideas, and innovations you need to do more in the electronics manufacturing industry. From optimization to operations, join us as we put the pieces together for a better approach to manufacturing. Let's go.
This is Hardware is Forever. I'm Chris Mitliff. Jay Patel is the CEO at Amtech, as always, and we are joined today by Dana Korf. And Dana, it's great to have you here. I love when we get to talk to other sort of business minds and business leaders, and Jay has such an interesting take on a lot of things that it's always fun to sort of connect with others and see where there is alignment and where there's something to learn. So welcome, and I guess introduce us a little bit to what you do, how you do it, why you do it. Share a little bit.
Okay. Yeah, I started back in this path probably started back in the 60s, I guess. I took an electricity class in high school, and we made a RF radio in a cigar box with a vacuum tube. You know, date myself here. And our job was to receive one radio station. And the net result was we jammed everyone's TVs and radios around the high school.
That's fantastic.
Wasn't quite a production unit just yet.
It's an unintentional hack of the entire comms system.
Yeah. Oh, we got in trouble by the police every year, so it was okay. Yeah. And so I got me interested in electronics. So I just started getting old tube radios and old tube TV sets and take them down to my bedroom. I took them apart and tried to make them work again. And that's what got me going into electronics. Just really something that simple. And I came out kind of at the post end of Vietnam War. I didn't have to go to Vietnam, fortunately. But so going to college is, if you were a double E degree, you got in. It didn't matter what your grades were, you got in. So that's the path I headed down as an analog designer. You know, just transistors and resistors, capacitors, analog ICs. And my project at college, my senior project, was designing a heart pump. We had a pump from somebody, and I had to design a timing circuit to inject blood into a horse, so I could track the whatever they were pumping in the horse's veins and trigger it off the heartbeat. So I did the circuit. I milked it pretty good, get as much money as I could, being in college. And we went into a veterinary pharmacy building. When they had the horse hanging from the ceiling, I brought my little circuit in. They put the pump in. I turned it on. I did the adjustments for them, and there was blood everywhere.
Oh, no.
I said, okay, I'm not going into medical. So it actually worked. Actually, I saw it on an old TV show. That's incredible. Years back in the 70s, I actually saw it on TV for another reason. I went, hey, that's my circuit, my first one. So I got hired out of college to work in the mini computer industry, and I didn't really know what I was going to be doing. I wasn't a digital designer. And they brought me in, and what got me going was I had to develop transmission design rules for the digital. It was called TTL back then, and ECL and CMOS circuitry, so you can figure out how fast a signal would propagate down the trace, and what kind of losses there were. Back then, it was all manual. I had SPICE that we ran very slow, and basically paper. Spreadsheets weren't out yet. So that's what got me into circuit boards. So I tried to understand a circuit board, how it worked. Now, we built a board fab shop. This is in North Carolina. We built a shop. So I went over there and helped build boards for a while to try and understand as an engineer. And that got me going into printed circuit boards, eventually into fabrication. Back in the 80s, I started a company, co-founded a company with a bunch of guys from Tektronix, a couple others. We had the first laser via patent in the world. We had the first, what turned out to be an EMS company. I think Jay can understand that. We board fabrication, board design, and assembly for anything that had laser blind vias in it. Very small company. And that was really fun, very intriguing. But unfortunately, we didn't know how to run a business. So that died off. And so I went over into the telecom industry, worked for an old boss of mine back in Atlanta, designing the fiber to the home products. Back when it was illegal to send video and voice over the same phone line. So I did that, some remote telecommunications packaging. So I got me into the telecom industry. Then I got called in to go out and work in the board fab industry in California for 5 years. It's going to go for 5 years, move up to Oregon. But 18 years later, I moved to China instead. So, so I think it's funny when I talk to students, they go, "What was your 5-year plan?" I always laugh. Plan? I never in my life would have thought I would have worked in China. Trust me. And so I worked for a large company over there, a huge telecom company called Huawei, who's now one of the banned companies in the U.S. And I was their PCB expert, they called it, charge of everything from scales in the bathroom to RF antennas, cell phones, high-end telecom equipment, all the circuit board technology. And the story I tell people about that is my boss, who spoke no English, they brought me in to bring the company into 4G. This started at 5G. It's back in 2011. And so I analyzed the whole Chinese industry. I traveled around the world with the guys looking at board shops. And I came back and said, well, China's not going to get there in the next 5 years. So I need to go to the rest of the world. And he goes, no. And this is through translation. I said, nope, it has to be 99% bought in China. So I did a quick calculation, 5G's 2020. Okay, we'll be under 1% for a long time. I said, okay, I'll be okay. They said, no, all China. So I looked at him. I said, so I can use Taiwan? And went over. I saw him smile. I heard my name. He came back. He said, not for you, Dana. He knew what I was trying to do. So did that for a few years, and then went over work for a board shop underneath Flex in Zhuhai. I was in Shenzhen, China, and worked for a board shop, Multec, for 4 years, doing boards. All this time, my board fab experience over 30 plus years was working with customers on design, trying to figure out how to get their design to be built properly, working with them during design. And so today I retired from China, came back in when did I come back? In 2019, retired for about 3 weeks. I just couldn't do it. So I'm going to take on a problem that no one's working on. I have a lot of peers in their 70s, 80s, and 90s, and said no one's working on this data transfer problem. For some reason, this industry can't transfer a design from design to manufacturing that can be built. So I'm going to fix that problem before I die. When they put me in the ground, I'm going to fix that problem is my goal, my life goal. So I've worked with CAE companies. I've worked with many board shops. I write articles for iConnect 007 Design every couple of months. It's called Dana on Data, great name. Writing about how to get jobs better, how to complain about the industry not doing a good job. I irritated people at Cadence one time with an article. I said, that's great, it's working. So
somebody's reading it.
Someone's reading it, yeah. And now I'm working on the new printed circuit board handbook edition that's been around forever. We're working on edition number 9, a section on printed electronics, additive manufactured electronics, and also on data. So, and then my primary job now is working with a company called Victory Giant out of China, working their technical support over here in the U.S. and work with a lot of customers, mostly in the AI space right now.
Mm-hmm. Isn't everybody? What a fascinating story. When you're in this, I like how you said, I've got one more problem I really want to solve. Because I also took my boombox apart when I was a kid because I was curious how it went. And I can draw a straight line from what I do now, even though it has nothing to do with circuitry like you, to just a general curiosity about how do things work. Is that a through point for you? So as you're kind of like, I'm going to solve this problem, do you find that you have a curiosity that's kind of insatiable that you're always sort of trying to tinker with or learn or understand? Or what is your driving motivation to only retire for 3 weeks and get back into something?
Yeah, because I live in a great spot here on Puget Sound. It's a lovely place. It's good weather here in Western Washington. So it's real interesting. In my 40s, I was sitting by my pool, my house in California. I said, okay, what's the thread in my life? There must be some kind of thread, because if you look on the surface, I'm all over the place. I've designed concrete bunkers with equipment underground. What's that got to do with circuit boards? And the thread that's caught me interested, that keeps me going, is I like to have the problem when they say it can't be done. Mm-hmm. That's what gets me going. You can't do it. It's not possible to do this. And I've had great luck with teams and managers. Trust me, it's not just all me, in guiding teams and working with teams on work on problems you can't do. Example was at Bill Northern Research, the design cycle was 3 years. When we formed this group in Atlanta, there were 6 of us, all from different industries. Only one guy had telecom experience. And he said, you have 6 months to design this brand new product and get it to market. So I said, well, and the guys in Canada said, no, it takes 3 years. We had 6 months. So back then, this new thing called 3D solid modeling was being invented, where you could do a whole prototype on the computer. So we spent, this is what, 1980, this is what, 86, I guess. So we went out and bought a $35,000 Hewlett-Packard workstations, bought this new thing called Pro Engineer, Pro E, that we were a beta site on. And I worked with my manufacturing partners up in Raleigh, and we designed the first prototype on the computer. And where we could doors that open. I'm a double A, so this is all fascinating to me. I was working the battery systems and the wiring and all that kind of stuff. And the president of Northern Telecom, our parent company, came down one time to see what we were doing, because we were also launching the first fiber to the home. And one of my engineers, he brought him downstairs because all the rest of the company globally was used in CATIA wireframe. Okay, we were the only ones using 3D solid modeling. And he came down to my room to go look what we were doing. And one of my engineers had hooked up a fan under the desk. And so when the CEO of the company comes in, we were the second biggest telecom company in the world at that point in time. He comes down and Lamar goes, see, we can simulate fans blowing. Come look at it. So he leans over his shoulder and Lamar hit a switch under the desk and the air started blowing. And went, you can simulate airflow? I was about ready to kill him.
Oh man, that's awesome.
And he told him what he was doing, and everyone started laughing. It was man, I was sure my lab VP was going to just fire me on that second.
Yeah.
But so in the circuit boards, I've worked on these things where, okay, your data can't get better. You can't transfer it without being modified. I worked at a board shop. I said, all these designs are coming. We have to edit every one. Why don't we give our customers our design rules? And the CEO went, nope, that's IP. So I thought about it for about a year, and I went back to him. I said, no, how you build the board is IP. Not telling them what we want is not IP. So I took on that challenge and da-di-da. So I tend to go after the problems and the type of companies where I have a problem that people just say, you can't do it. It lights my fire.
So I think where Dana and I intersected was, although I build electronics, I don't know how to design electronics I'm not an engineer of electronics. I'm a process engineer or a process developer for that. And I think that's where Dana and I really came into play. I think we were looking at, we lose a lot of time consistently with every single interaction when it comes for a new product being launched. And that type of, the data that we get is not good. I think this is what Dana was referring to, is the data that we get is not good. It is not consistent. It's not standardized. So in the electronics industry, there is no standard data format. So every time we get something new, we have to dissect it like it's something new. So every time we get it, and sometimes if we're lucky, we get it right. And if we're lucky, we get second or third chance to get it right. But otherwise, it always leads to a lot of risk when launching electronic products, whether, regardless of complexity. If the data package is not good, it's not good. And through this journey of trying to standardize and understand what the standards are, I got introduced to Dana because we have a little bit of project that we're working on at Amtech to kind of standardize this and automate it, so then we can launch products quicker. That supports onshoring and reshoring in the United States. And then so I got introduced to Dana, and then Dana it's just a wealth of knowledge. He just kind of did a little bit of an introduction to himself. And, we were talking, and I don't know, I initially shared with him, I don't know if this book is there, but
Blurred.
He told me about this book. It is Soul of a New Machine. I told him why we named our podcast Hardware is Forever. He's like, yeah, there's a story about that I worked on too, and it's in a book called The Soul of a New Machine. So I think there's a lot of although our approach and role in the industry is different, we've intersected. And man, he's one of those guys that is a treasure in the entire industry. And I think that's where we really connected. And I think specifically we connected on IPC 2581. And that is the standard that Dana, how he said he wanted to solve one more problem. I think that was the problem that he was trying to solve, is how can we get information back and forth from designing to manufacturing, so then we can all be on the same page and use our resources to add value rather than consistently trying to mitigate risk and hope we get it the right way the first time.
As I know you, Jay, to be a person who is always looking for the template, give me the things so this becomes more efficient and simpler, and whether that's a framework or a practice or a way of thinking. Do you feel like it's I don't know, you've met a kindred spirit who also, has this crazy wealth of knowledge in your specific kind of expertise to sort of learn from and bounce ideas off of, or just soak things up? Like, what is your relationship to all the things that Dana knows?
Well, I think I'm just at the tip of the iceberg with this IPC 2581 stuff. I haven't learned too much, and I'm Dana. I'm sure you'll concur. You have a lot more value to add than just our one conversation that we had. But I think, what brought us together was really the IPC 2581 and our mutual feelings, because it is not as ubiquitous as it should be, because there is really not a good reason that it's not. And I think that's where we're working with IPC, we're working with other industry standards, we're trying to work with, Dana's done a phenomenal job with working with the ECAD companies to make IPC 2581 integrated into their software as an export format. And the real question was, like, how can we get IPC 25, like, why IPC 2581, what went into it, and how can we get 2581, how can we work towards getting it more adopted? And I think one of the first steps is people just don't know what IPC 2581 is. So Dana, if you want to share that a little bit and what the advantages are, and then we can try to share that, and then also we can try to talk to our peers. I mean, there's a lot of things that we can do that I'm hoping that we can collaborate with to try to make. I don't know if we can make IPC 2581 mainstream, but at least we can make it so that people are more aware of it, because I don't even know if people are aware of it or not.
Yeah, it's kind of a combination of things. Chris, one thing when I started looking at this problem a long time ago, how do I solve this? I started analyzing all the issues, made a huge spreadsheet, and it kind of looked, why do we have issues back and forth? It doesn't matter if it's assembly or fabrication. So I broke it down into really simple problem. First was the file format itself. Okay, we keep talking about we can build from Gerber files. Actually, you can't build anything from a Gerber file. All it tells you is where the lines and the round things are on a layer, and that's it. And you know what the layers are, what their function is. That's actually what a Gerber file is. So it has to have all these additional files to go with it: drill files, fab prints, net lists, all sorts of documents to go on to actually build something. So the file format. So back in the 80s, IPC, I was on the committee, developed IPC 350, which nobody used, but I had a net list. So I said, okay, we're having problems reading these Gerber files, so let's compare it back to the net list. Okay, that solved one problem. Well, 40 some years later, now the net lists are all bad. The files are good, the net lists are bad. And I'll talk about that a little bit later, mention something about it. So there's the file format. The next one are design errors. Okay, I tell people, I teach a DFM class for IPC. I actually had a session this morning. So I say, okay, as a fabricator, what's a design error? I asked groups of very large tier 1 companies in a meeting last month, what's a design error? They're all looking at each other like, I don't know what you're talking about. I said, well, as a fabricator, I can put solder mask on pad really easy. Actually, it's easier than keeping it off. I can put your U1 indicator on top of a soldered pad. That's really easy to do too, okay? So I'll do exactly what your artwork says. I'll cover all your pads with solder mask. I'll put legend all over the stuff you want to solder to, and we'll ship the board. Maybe a little difficult to assemble, but I made it exactly per your documents. So I go, they go, what are you talking about? So, well, you told me to put solder mask on that pad. You told me to put legend on that pad. You told me the board size was 2 different sizes. I picked the wrong one. So we're actually, a lot of the issues we have is actually the way the data is designed incorrectly, because the CAD tools let you do anything you want. The other one is that our side, the fabricator, we don't really tell people our capabilities are very well. Like, as I mentioned earlier, some guys think it's IP. Some people don't even know what their own rules are in their shop. And how well can you document it for your friend and people to read data in, and how much do they help? There's a subset of that you go to tell a customer. And so 2581, why did we do that? We want to solve the documentation, the file format problem. We can't stop designers from putting solder mask on pad. Data formats can't do that. I can't make a fabricator tell people what their capability is. But the data format and multiple file problem Gerber is about half the problems we deal with. Assembly or fab. The documentation tells you to do something different or do something dumb. So we have to call back and say, what do you want to do? So 2581, the concept was, we started this, and it's actually 25 years old now. The concept was, we want one file, and it has to be intelligent. Okay, a Gerber file starts in a CAD system. They say, I am net name clock 1. I am 5 mils wide. I have a 10% tolerance. My impedance is 50 ohms plus or minus 5%. And I have a signal loss of 0.19 dB per inch. All that is in the CAD system. When they create a Gerber file, they take all that out, put notes on a drawing, comes to me or to Jay. We have to type it all into our systems again. Well, I don't trust humans typing. Okay. So the data format of 2581 was to create one file, make it intelligent, and make it bidirectional. So if I edit something, you can send it back to our customer. They can load it directly in their CAD system without them typing it in again. Now it's the core of the whole format is, let's have one unified file. Yeah, it's going to be big. Who cares? It's the internet. Who cares what file size it is? And send all that intelligence that we need to build a board, not to design it, but to build it. And also in that file, I want to include assembly and test information. So all I have to do is one output. I can fab it. I can create a stencil. I can assemble a board, build materials, AVL, all that stuff, pulled from the system, sent automatically. It can be read in automatically. That was the premise for 2581. Now, the issue that Jay refers to is this industry hates change. I mentioned we patented the laser blind V in the early 1980s. 20 years later, it became common in cell phones. Everything happened in multiple decades in our industry. They hate change. And so we have a lot of companies that do 2581. We have very large companies that are just starting to do it since DAC goes back and forth. Assembly uses it more because it solved the bill of materials and all that issue real nicely. So you see more use in the assembly side, actually.
Dana, thanks for joining us today. Really fascinating stuff. And really, come on back and we'll have part 2 and 3 and 16 of this conversation, because it looks like, it seems like it's an interesting one and it's ongoing.
Yes. Thank you.
Yep.
Thanks, Jay. We'll talk to you next time.
All right.
Thanks for joining us, and a special thanks to our subscribers and followers. Consider becoming one today wherever you get your podcasts or on YouTube. Hardware is Forever is designed, tested, engineered, and built by the manufacturing experts at Amtech. Learn more and let us help you envision your next project with a free Design for Manufacturing assessment at buildamtech.com/DFM.